Uh, Hi guys, today I'm gonna talk about the calculus and integral. And first of all, I'm gonna start with the continuous function and what is like continuous function and what are the terms to determine the continuous function. And the next one I will talk about the indefinite and definite integrals. And then I will end with the example problems and how we can find indefinite and definite integrals solution. First of all, let's talk about continuous function. So if what is continuous function? It's like if a function f is a continuous at any given a number, if a limit of fx equal to fa, and as x approaches to a. So let me draw the graph for this so that it can be easy to understand. Y, x. So this is our graph, and this result will be fa, and when fa intersects on the graph here, and this will be our a, and so approaches here, and a will be approaching here. So this will be our fx. So first definition will be if a is defined, and that is a is in the domain of f. So that basically means in a number should be defined in fx function. And that will be our first term to check. And second one is it should be the limit fx exists. And then the last term will be limit of fx when x approaches to a, that it should be equal to fa. So it will be our continuous function. And now I'm gonna jump on to indefinite and definite integrals. So let's start with the indefinite integral. Indefinite integral. So definition is the set of all antiderivatives of a function fx is the indefinite integral of fx with respect to x, and denoted by like fx dx integral equal to big F x plus c. C means constant. So this is our integral symbol, and fx dx, this is the derivative x equal to big F x and plus c. So this will be indefinite integral, and the second one will be definite integral. Definite integral. First fundamental theorem of calculus states that if f is continuous, as we check by this, on the closed interval a to b, and big F is the indefinite integral of small f on ab, then we note this like integral symbol. So integral will be here, bottom lower level and the upper level. We say it's a lower limit and upper limit of fx function derivative x equal to big FB minus FA. So let me re-say this. So on the closed interval of AB, so we denote by like this. That means A is between A to B. X is between A to B, and this is a lower level and upper level. And big F is the indefinite integral. Big F is indefinite integral of small f function on interval A to B. Then we write it like this. So let me explain this furthermore. So that means it's x is between, x is between a to b. So closed interval is an interval that includes all of its limit points. So let's jump on to the example problem. The first our problem will be five x to 6 plus 2x to 4 minus 7x minus 4 dx. Actually, yeah. Okay. So, all right, let's find a solution for this equation of that integral. So basically, integral means the integration of all antiderivative numbers. So we know that derivative. Okay, when if fx, this will be just another example. If fx is like 4x, the derivative of 4x will be if x will be 4. So what I mean for antiderivative means like this is derivative, so this will be antiderivative. So in any x number, integral of a x n equals to a divided by n plus 1 times x to the n plus 1 power, and then we don't forget the constant. Okay, this is important, and if it's an indefinite integral, we should always include the constant. So we will apply this rule for any x powers in this function. So 5, that will be equal to 5x squared. 5x squared will be, we add 1 to the power, so that means 6 plus 1 means 7, so x to the 7 power, and then be divided 5 divided by 7, and plus here x to the 1 is x plus 1 is 5, and then 2 divided by 5, and then 7x to the 1 plus 1 is 2 divided by 2, and we here minus 4x. And now we have one more thing to do, which is our plus sign. So we basically apply this rule for every x powers. And one theorem says that all polynomial functions are continuous function. So we don't have to check if it's continuous or not. This is polynomial. And so second one will be 2, problem number 2. Oh, this marker is pretty good. So let's put the limits for our integral. So it could be any number, like we say 1 and easy number 2. So this is our closed intervals. And then let's take this example for our function. Plus 2x4 plus 7x minus 4 times dx. Yep. Okay. So we know that this is equal to 5 divided by 7, x to the 7 power plus 2x to the 5 power, and divided by 5 plus 7 divided by 2, x squared minus 4x. And now we don't need to find the x because we have the limits now. So we put it like here, 2 and 1. So we jump on this definite integral term. So the big F, we should apply number first b. B is our upper limit first. So we will plug 2 in every given x. So it will be 5, 7 to the x. X is like now it's 2 to the 7 power. And plus 2 x is now 2 times 5. No, and 5. X will be 5 power. 7 divided by 2. X is now 2. And minus 4 times 2. But this will be our first one. It is now, it's a FB, big FB, and minus our second equation, 5, 1 to the 6, 5 divided by 7, and this will be 7, and plus 2 times 1 to the 5, divided by 5, and 7, 2 times 1 squared, and minus 4 and 1. Okay? So now we need to calculate what's here and what's there, and then we can find the solution. Okay, hey guys, I found my magic calculator. So now let's calculate it. So first BDF equation will, when we apply the 2, will be 640 divided by 7 and plus 64 divided by 5 plus 7 divided by 2 minus 8. And now the second F, when we applied 1, will be 5 divided by 7 plus 2 divided by 7, no, it's 5, and plus 7 divided by 2 minus 4. Okay, so we can give 5 here, we give 7 here, and these 2 will be cancelled, and we put 35 here, and we put 5 here, 7 here, 35. So bottom side will be 35, and from first one we get 3,175 plus 434 minus 140. And now we go back here to find our exact solution. When we calculate again, okay, 3,469. Okay, so that's it. It's easy. Calculus and integrals are easy. You just got to put efforts into it and calculate, and so it's that's all.